Alright guys, sorry that I'm going today. I had terrible migraine all night, so I didn't sleep, and I'm going to try and get some rest today. Today we are graphing logarithmic functions as inverses. So a common logarithm is a logarithm that has a base of 10, and we don't even write the 10 down there. So if you don't have a base number, you can just put it as 10 right there. And what you need to know is that a logarithm is the inverse of an exponential function. So if you know the coordinates for an exponential function, and it's in the form y equals some number to the x, you take the x and y coordinate for this function, and then to graph the point for this function, all you do is change the y and the x their place. So I'm going to show you what that means. We said y equals log to the log of x. The base that wasn't written was 10 right there. Now 10 to the x is our original function. Log base 10 of x is our inverse. So let's say we have y equals 10 to the x. And we will make a table of values for this. Okay, negative 10 to the negative 2 is 1 over 100, or 0.01. 10 to the negative 1 is 1/10, or 0.1. 10 to the 0 is 1. 10 to the 1 is 10. 10 squared is 100. Now, to graph log base 10 of x, all you have to do is switch the x and the y coordinates. So x was negative 2, now y is negative 2. Y was 0.01, now x is. Messed up there. So I've got 1, 10, 2, 100. And that's what I want to graph. I want to graph these points. So I say x is 0.01 and y is negative 2. So let's say the point would go right there. 0.1, negative 1, so it would be right maybe there. 1, 0, right there, a little bit easier to plot. And then 10, 1, and then 102, that would be way off the graph, but what it would look like is this. Keep going. The original function, if I had graphed it, we'd have negative 2.01, that would be right there. Negative 1.1, 0, 1, 1, 10, and then 2, 100. So it would look like this. And what you see, and actually this would not cross the x-axis. For the original function, the x-axis would have been the asymptote. On the inverse, it's the y-axis that acts as the asymptote. And what you see is that they are a reflection of each other over the line y equals x. That line right there. Obviously, I was trying to draw this fast. And that's how you do it. Next one, log base 2 of x. So the original function, before we took log base 2 of x, it was y equals 2 to the x. So if you want to do your x and y coordinates for this, negative 2, negative 1, 0, 1, 2, we get 1/4, and then 1/2, 1, 2, 4 for log 2 of x. Switch those x and y coordinates. 1/4, -2, 1/2, -1, 1, 0, 2, 1, 4, 2. Plot those points. 1/4, -2, right there. 1/2, -1, right there. 1, 0, 2, 1, and 4, 2. Same thing. It's the y-axis that acts as an asymptote. Make sure this is still recording. Good. Same thing with log base 3 to x. So y equals 3 to the x. Make your x and y coordinates. Plot those points. 1/9 -2, 1/3 -1, 1, 0, 3, 1, 9, 2. Now if I want to translate, what I do is act as if I just have this section, and then I translate left and up. Or if it was plus h, then it would be, or excuse me, if it is right and up, if it was plus h, then it would be left. If it was minus k, then it would be down. So this is how it works. We know that the shift, according to this plus 3 inside of parentheses, is going to be left 3. So I only act as if I have log base 3 of x. The original function, this is the inverse of y equals 3 to the x. Find your points. We already just did this. Let me rewrite it. Okay, so what I have is log base 3 of x. But this right here, this plus 3, shifts it left 3. So that means that the x coordinates are going left 3. Or subtract 3 from all these coordinates. So what we're going to have, and what you could do is plot all these points and say, okay, I have 1/9 -2 right there, 1/3 -1, 1, 0, 3, 1, 9, 2. And then just say, alright, well, in a different color, I'm going to shift all of those points left 3. So I go to this point, I go left 1, 2, 3, It's now right there. Same thing with this next point. 1, 2, 3. For some reason it's not leaving it on there. This point, 1, 2, 3. And this right here is the final graph. So that's one way we could do it, or what we could do is just subtract 3 to get the coordinates of all of those points. If I want to graph log base 6 of x minus 2 plus 3, what I know is that the parent function is log base 6 of x minus 2 means right 2 inside the parentheses, plus 3 is up 3. So I know I'm going right 2 and up 3. So I say to myself, log base 6 of x is the inverse of y equals 6 to the x. Makes it your x and y table. Negative 2, negative 1, 0, 1, 2, 1/36, 1/6, 1/6, 36, log base 6 of x. We just have all of those swapped. 1/36, negative 2, 1/6, negative 1, 1, 0, 6, 1, and 36, 2. So you could plot all of these points and then move all those points right 2 and up 3. Or what you could do is say right 2 would be adding 2 to the x, all those x coordinates, and then up 3 would be adding 3 to the y's, and that's all you would have to do. So the way I'm going to do it is actually doing that. I'll say 1/36 plus 2 would be 2 and a 36th, so it would be just past 2, and then negative 2 plus 3, so let's make a new table of values here. So 2 and 1/36, and then negative 2 plus 3 is 1. 2 plus 1/6 is 2 and a 6th. Negative 1 plus 3 is 2. 1 plus 2 is 3. 0 plus 3 is 3. 6 plus 2 is 8. 1 plus 3 is 4. 36 plus 2 is 38. 5. Those are the points I want to graph. 2 and a 36th would be right past it, and go up to 1. 2 and a 6th would be just past it also, and go up to 2. 3, 3. 8, 4. 38, 5 would be way off. And what you see is that my asymptote, it was originally the y-axis, but since we moved the whole graph over to right 2, therefore my new asymptote is the vertical line x equals 2.